starting out with our notes page because, as they often do, they don't give us enough information to talk about stuff they don't find. So, first thing we need to know is this: the angles. So triangle angles, add to 180, right? Any quadrilateral, it's just a four-sided polygon, right? The angles add up to 360 degrees, all four of them, right? It doesn't mean they're all 90, right? It could be, but they add to 360. Now, here's another thing you need for one of the proofs later on. Parts of parallel lines are parallel, right? So if you're told that AC is parallel to AF, then you can also say that AB is parallel to DE, right? And there's a proof in one of the Regents questions that kind of makes you do that, right? You'll see what I mean. But you can justify, if you're given that, like in the given, you can then in one of your statements say AB parallel to DE, and your reason will be parts of parallel lines are parallel, okay? And so here's some other proof things that you might need. If I have two lines that are perpendicular to the same line, see these two lines here, perpendicular to that line down there, then these lines are parallel, okay? And that makes sense, right? Because then you'd have your corresponding angles congruent, wouldn't you? And then by the converse, right, the corresponding angles congruent, lines parallel, okay? So if they're perpendicular to the same line, they're parallel. Now, if two lines are perpendicular parallel lines, then they're also parallel, which is kind of a corollary of this other one here, okay? So if AB is parallel to CD, and these guys are perpendicular, then EF is parallel to GH, okay? All right, so we kind of need to know those things for certain other things we're going to talk about. Now, we are going to talk now about quadrilaterals. And the way they set it up here, the way they organize it in this table, I don't really like it. Maybe you will, okay? So the first type of simplest quadrilateral is just no restrictions on it other than it's got four sides. It's a four-sided polygon, okay? We're not saying any of the sides are congruent to each other. None of the sides are parallel. No angles particularly equal or anything like that, okay? Just four sides is all it's required, and that's a quadrilateral. So then when we start adding restrictions to that simple definition, then we get more specific quadrilaterals. So for example, if I take just a regular run-of-the-mill quadrilateral, and then I tell you both pairs of opposite sides are parallel, well, that quadrilateral now becomes a what? Parallelogram. It's in the name, right? Both pairs of opposite sides are parallel, okay? And I think what we should do here is they have it down here. Let's go. There's a page I included here with a little flow chart. Go to that page. So if you look at this flow chart, I can tell you since they switched to Common Core geometry, they pretty much eliminated kites. So you don't even know anything about that. And they don't do a whole lot with trapezoids and isosceles trapezoids. Now and then you'll see it, right? But I would just be familiar with this part, okay? We're not going to get too crazy about it, but just kind of know that. But what we're concerned about is right down the middle, all the way to the bottom, okay? So run-of-the-mill quadrilateral, that's the definition. Four-sided polygon, and the only quality it has is that the angles add to 360, okay? Now we put a restriction on. Now if we say that quadrilateral gets both pairs of opposite sides parallel, it becomes a parallelogram. And that's the definition. Quadrilateral, both pairs of opposite sides parallel. And by the way, that definition is also a property of it, okay? Now once it becomes a parallelogram, right, all these other properties are true. So if we make this a parallelogram, not only do we have all the parallel sides, but both pairs of opposite sides are what? See, they're congruent. Both pairs of opposite angles are what? Congruent, okay? Consecutive angles, right? That means one right after the other are what? They add to 180, okay? And when you draw diagonals in this parallelogram, what do the diagonals do to each other? Bisect each other, okay? So, and these are properties that you will have to commit to memory all the way down this thing. And there's a quiz I'm going to give you at some point, right, to make sure that that happens. So give you a little inspiration to memorize this stuff, okay? So now let's start with a parallelogram, right? It's got all these properties, but is it also a quadrilateral? Is it? Yeah, it is, right? And so it also has angles that add to 360, so it has the property too. But now let's take the parallelogram and give this parallelogram 4 right angles. What does that make it? A rectangle. So we put another constriction on it, 4 right angles, it makes it a rectangle. And that's the definition of rectangle, a parallelogram with 4 right angles. When it becomes a rectangle, we get more properties. Well, of course, the 4 right angles. And now, if you have a rectangle, what about the diagonals? They are congruent. Okay? Let me ask you this. Is a rectangle also a parallelogram? Yes, it is. Okay? It's a parallelogram with 4 right angles. So will a rectangle have all of these properties as well? Yeah. And of the quadrilateral up there. You follow me? Okay, let's go back to parallelogram. A parallelogram, if we start with that, no more right angles. Now let's say the parallelogram gets 4 congruent sides. What does that make it? Rhombus, not necessarily a square yet, right? But a rhombus, okay? So if we put a restriction and it has 4 congruent sides, we now have a rhombus. Parallelogram with 4 congruent sides. So the bold print is like the name and the definition of each. And that definition is also a property of it, okay? And then additional properties. When that parallelogram becomes a rhombus, the diagonals are perpendicular to each other, okay? Which then means, wouldn't that create like a bunch of right triangles inside the rhombus? Yeah, okay. Keep that in mind. The diagonals also bisect the pair of opposite angles. So the diagonals come from angles. The angles they come from get bisected by their diagonals, okay? So you got to know these properties. So now let's say we combine rectangle and rhombus. And they get together, you know, moves right, and they have a little child here. What do they name their child?
Square.
Square. So this child square has the DNA from both parents, doesn't it? Right? So if I take a rhombus and tell you that rhombus gets 4 right angles, what does it become? A square. Well, if I had a parallelogram, or if I had a rectangle, and so now my rectangle has 4 congruent sides, what does that make it? A square. Right? So now a square has 4 congruent sides and 4 right angles. Is a square a rectangle? It is. Not necessarily, not until it gets 4 congruent sides. Right? But a square is always a rectangle. So everything down here is always the thing above it. Is a square a rhombus?
Yes.
It is. Is a square a parallelogram?
Sure, yeah.
Is it a quadrilateral?
Yeah.
So all the way down here, it's got these properties. It also has all the properties of rhombus, wouldn't it? Because it's a rhombus. It also gets all the properties of rectangle, all the parallelogram properties, and all the quadrilateral properties, okay? So you'll want to reference this flowchart, I think, as you're doing homework and whatnot, and you are going to need to commit this to memory, okay? A lot of people just doing it over and over again. But this is one of those things where you don't do that often in school, but like rote memorization, you might have to just sit and just write each one down over and over again, right? It gets in your brain, okay? Because it's not going to be on any kind of formula sheet on the state test. They assume that you've memorized this, okay? You can work with it. Some kids like the way they lay it out here. It's kind of the same as what I have, but I don't care for it. It's not organized. My brain organizes definitely more discreetly than what. So either one. And in fact, I'll give you this, like to keep from flipping pages, because you're going to want to do a lot of flipping back and forth. So I'm going to pause this. So parallelogram, both pairs of sides parallel. That's a definition, and then it gets all the other properties below. Remember, in that flowchart, the definition is also a property, okay? In a rectangle, parallelogram, 4 right angles. You get the idea, right? Okay? Let's flip over to the next page. And when you get a problem with a quadrilateral, the most important thing to notice is what they say it is. That'll tell you what properties it has and tell you how to work around it. So as soon as you see that's a parallelogram, right now, you want to get your flow chart out and just go, okay, these are the properties of a parallelogram. That'll help me figure out what I need. Does that make sense? So always make note of what they say it is. So in this one here, the missing information, will be, I guess X is that angle up there, right? And Y is this segment here. Now, it's a parallelogram. Let's not forget this, guys. That means, hey, what do we have here? Parallel lines and transversals. So we're connecting stuff back to that, right? So it doesn't go away, guys, okay? I hope you didn't think that we're done talking about parallel lines and transversals when we switched over to parallelograms. Not it is, right? It's in the name, okay? All right, so how might we find angle X up here? Parallel lines, transversal, alternate interior angles with that 13, right? So X is 13 degrees. Get the idea? And how about Y? What property of a parallelogram helps us find Y? Look at your flow chart. Diagonals what? Bisect each other. So what's Y? 3.2. Same as that other one, right? Now, first thing you should note, what is the shape? Now, you got rhombus on your flow chart with properties, and you also don't ignore parallelogram properties because it's one of those, too. So, let's see about finding X here, because you know it's, if you didn't know it was a rhombus, you'd be, you know, twiddling your thumbs there. So, how do we know what X is? What's the definition of a rhombus? No. Parallelogram, 4 congruent sides. So what's X equal? 12, right? And Y is going to be that angle. Oh, well, that's an angle. What do you, property of rhombus? Angles, what about them? Find something about angles and rhombus properties. What about opposite angles? The diagonals do something. Diagonals bisect opposite angles, right? So that means that and that are congruent, right? So Y has to be what? 68. What is the shape here? All right, you got it on your flow chart. Properties of the square. It's all the way at the bottom. So it has all the properties that came before it, right? Okay? So X, what about it? Because it's a rhombus, right? And how about this angle Y right here? The square's a rhombus, isn't it? Why is it 90? Because in a rhombus, what? Everybody looking at rhombus on their flow chart? Why is that angle 90? Diagonals are perpendicular to each other, right? So really we got, didn't that give us like 4 right angles here? Okay, and 4 right triangles, yeah? And, maybe Pythagorean theorem stuff even? Yeah, okay. All right, let's move along here. So I want you guys to take a minute, and they have an X here, and Y is AC. They put it down here because if they put Y in either spot, it would look like half of it, but Y is the whole thing, okay? So I want you guys to take a minute and solve for each one of the variables they have, okay? Note the shape, okay? And also in B, they gave us some information. Don't miss out on that, okay? Was there a question?
Yeah, so it's Y, the opposite side of the
The opposite side,
or is that the
AC.
bisect?
AC
So
is the that's Y, that whole diagonal, okay? All right, I'm going to pause this. You guys work through that. Well, how do you figure that?
it's 72 and that's right.
It's a rectangle, so it's a right angle, right? So these are complementary angles. They add the 90, right? Complementary angles. That's kind of sloppy, right? It's a CO, I think. All right, so that means that X plus 71 equals what? 90. X equals 19 degrees, okay. Well, what about Y? You had what for Y? So there's what Y is. Anybody else get 12 for Y? Anybody get something different? You got 12 for Y? So that diagonal can be the same length as the side of the triangle? What does your intuition tell you? Can it be 12? What do you think?
15.
Shot in the dark?
Yeah.
Okay. False, not 15. Thanks for playing though. Oh, guys. Kind of triangle is that? Oh! What's that? What are we going to use to find? Yeah, try it now with the Pythagorean theorem, unless you remember a triple.
I know the answer.
Hang on, we'll let the other chimps take a shot at this here. Okay? We'll give you a minute to work that out. All right, Mr. Morley, what you got?
I got 3 chicken tenders.
13.
Boswick, Hurd, Walburn. Now, come get it.
Yep, get your nuggets.
Come to get nuggets.
Nobody got
Ryan Boswick.
Boswick.
Yeah,
No
that's
Boswick in
Wrong
here.
class. They went the wrong one.
13. And we got 13. Shows you did y squared equals 5 squared plus 12 squared, right? Y squared equals 25 plus 144, yeah? Y squared equals 169, square root of both sides, y equals 13. Or, guys, is this a triple? Am I writing in green? Or, you could have done this. There's a triple. See how, if you can remember those, you don't have to, but see how easier it makes life? Right? 5, 12, 13. What's the first one we talked about? 3, 4, 5 right triangle. 5, 12, 13. What was the one we looked at today? Was it like 8, 15, 17?
No, 8, 10, 12. 16, 10.
Something like that. Yeah, I can remember now.
That's 9, 12.
9, 12, 15.
Was that,
Oh, that was
okay.
8, 10, 12, 16, 10.
Well, that's a 3, 4, 5.
Yeah.
6, 8, 10. Yeah. I don't know. I was looking. Anyway, how about the second one? Anybody get that yet? What'd you get for X?
6, 7,
Oh, well, how'd you get that? Look at that. See that?
8, 6, 12.
So that's 12. So X equals Y. What property? What tells you that X is half of that 12? Yeah. I don't remember midpoint being. I don't remember that being any of the properties on your flow chart. You're right, but on the wrong tree. Well, that doesn't give us that they're equal. Well, we're not talking about opposite angles. So you're looking in rhombus, you're not seeing it, but don't forget, it's also a parallelogram. Go with the parallelogram. You feel me? Diagonals bisect each other, right? So X equals half of 12, which equals 6, okay? So we got to know, remember, it has the properties of everything that came before it too. What about Y? I guess that's that angle down there. Because this is important, right? BCD, this whole thing. Now look, you see how remember I told you, like, if you're doing congruent marks and something like that, offset them a little bit so it doesn't look like this. What I do here is, if I just write in 68, you might think it's just this angle here, right? That's why we can put that whole arc in there. That indicates the whole thing is 68. That's why I took offset them, okay? So, all right. So how do we get Y? First of all, what's the measure of that angle? Because it's a parallelogram and opposite angles are what? Okay. And now because it's a rhombus, opposite angles are bisected by the diagonal, right? So Y equals half of 68, which is, right? So a parallelogram makes the opposite angles congruent, got us to 68, and because it's a rhombus, it has a property that the diagonals bisect the opposite angles. And C is a parallelogram. What tells you have, and all these, by the way, you still have parallel lines you could have worked with, right? Because they're parallelograms. But I think we kind of have to over here. Well, let's see. What might be the measure of X?
36.
Y. Okay, reflects, but let's stick, yeah, you're connecting things, that's great. But right now I want to stick with properties of parallelograms. I'm glad that you made that connection.
Opposite sides.
Well, parallel lines and alternate interior angles is what I'm getting at. Right? So X is 36. So alternate interior angles, right? Congruent. So X equals 36 degrees, right? So we'll put that in there. Well, how might we find angle Y? Yeah.
I thought, it's a 62, like, goes up, dancing triangle or down.
Tell me why. Why is this 62? Yeah, right? You don't forget stuff. Well, how do we now get angle Y?
That's up for me.
Angle 180, right? So measure, I'll just put Y. So Y equals, because that's a triangle, minus 62 minus 36, and what do you get? 82 degrees, okay? So you have to be familiar with the flow chart. You need to commit it to memory as we go along here, okay? I'm going to give you a quiz on it at some point. I'll let you know what it is, right? So you can really buckle down and memorize. But in the meantime, try and get it to memory. Let's take a look at some Regents questions here. We're not going to get through all of them, so we'll do part 2 video tomorrow or something there. So have your flow charts ready. Well, this one isn't really, okay, well, anyway. I guess it doesn't connect directly to what we're doing. But let's read over this first one here. Oh, it does kind of connect, yeah, all right. I'll put those in while we're waiting. So angle A is 82 degrees. Angle B is 104. And angle L is 121. Find the measure of angle M. I'm going to put an X in here for an angle M. This is important, by the way. That and that, as you recall, is important, and perhaps a certain property of quadrilaterals is important. Well, tell me what you were thinking then. How do you not get that? Let's just say it.
Since L is 100,
Yeah.
and it wants to check how big is the wants to map on the JPL.
Rigid motion, mapping congruencies, right? Corresponding angles will be congruent, right?
And all quadrilateral, I can't say. All add up to 360. So just add them on to this.
Right? Quad angles add to 360, right? Okay. So how do we know what angle M goes with, though? That's the thing, right? Angle, look at up here. M goes with D, doesn't it? Okay, well, that doesn't really help us. What about angle K? We got to get at least 3 angles in one of these triangles. Let's get well, what does M go with over here? Yeah, so I'll put it in for D. How about I put that in there? So that'll be X. M goes with D. What?
I don't know.
Immediately.
L goes with C.
We need C. Okay, so L here goes with C. So C is 121, right? So we just use the properties of rigid motion and congruent corresponding angles, and now we need to know something about quadrilaterals, which is what? So wouldn't X equal 360 minus 82 minus 104 minus 121? So X equals 53 degrees. Follow me? Okay, so we're combining stuff here. Let me get through 1 or 2 more here. Let's go down to the next one. Very important to note when they tell you that, because then you go right to your flow chart to remind yourself of the properties of such a thing. And they talk about the diagonals of it, don't they? So you might want to take a look at diagonal properties for parallelogram. Okay? You say choice 2. Why do you say that? AS is half of AD.
Diagonal bisect each other.
In a parallelogram, diagonals bisect each other, right? So that's your properties on your flow chart. Diag bisect. Right? So that's got to be half the whole thing. Let's move on to number 3. Now, number 3, make sure you draw like at least a rough sketch of this and label it the way they say, okay? 'Cause I'm not sure I can really answer this without drawing it out, keep track of all that in my head, okay? So read that over. I'm gonna make a little sketch myself. What shape is it? So we'll draw it roughly like a rhombus. This isn't right, just as long as we know that. And VENU, VENU. And by the way, when we label, guys, any kind of polygon, wherever we start with the first letter, we go consecutively for the next one. And we could even go the other way. It wouldn't matter, right? But we could start V here to be ENU. Okay. The only criteria is that you go consecutively in one direction or the other, right? And then we got the diagonals here, this rhombus. So but you probably need to know something about rhombus diagonals. Intersect at S. Call that S. I don't need S. Then VN is VN is 12. So what does that make each one of these segments? 6 and 6. And what are these two segments? Okay. 8 and 8. That's an 8. And what do they want? Define the outside. So Pythagorean theorem will give us the perimeter of a rhombus. Oh.
The little triangles.
Oh, the little triangles?
Yeah.
We can use a Pythagorean theorem on any little triangle we feel like. Well, Pythagorean theorem is only for what kind of triangles? Oh, darn it. Well, this we're back to the drawing board. Huh? Those are right triangles? Well, it tells you that. I want to write. So this kid looked at his flow chart, didn't he? Right? He says the diagonals of the rhombus are perpendicular. That was smart of you to do that, right? Because that gives us some things. Like, that's a right triangle. So let's call this X. So what are we going to do here to find X? What? Are we going to do, say, certain theorem? Oh, Pythagorean theorem. X squared equals 6 squared, right? Or what? Or what? Is this a triple? A 6, 8. Because it's a 3, 4, 5 doubled, isn't it? Go ahead and do the Pythagorean theorem and verify you get 10 if you like. And see how nice it is now that you know a triple? It's a 3, 4, 5, but it's doubled, right? So 6, 8, 10 is really like in the family of 3, 4, 5, right? So instead of doing all this work, I could just say, hey, that's a 6, 8, 10. So X equals 10. And so it's choice 4, right? See what they do there? They're very diabolical. You got 10. You got excited, right? You're about to call mom and dad. I got 10. And it's one of the answers. They'll be proud of you. Call answer my whole family, man. They'll call the whole family up. We got 10. What's the problem? They want perimeter. So perimeter, and they're all equal sides, right? So we could just do 4 times 10, 40. That's a good question. You got 80? Did you draw 2 rhombi?
Sure.
I don't know. Maybe we can get this page now. See how long it goes. Let's go on to number 4. Read that over. First. What is the shape? Got it, man. If you don't stop that, then you're going to be floundering. Okay. That means you can't use properties of rectangle, square, right? So angle C is 7. Good, they got that in there. ROF, good, they got that in there. KSO. I'm going to put an X here. And I'll pause it you might be tempted here, right? Because you might be tempted, thinking, it's a parallelogram. And maybe I can do something with this transversal. Is that really what we got here? That will help us? Is that going to help us?
If you send it over to the
Right, so not with the so we're not working with a transversal. That's what he's getting. Okay, so why would angle R be 70 degrees?
Because
Parallelogram, opposite angles congruent. That puts us into this. What is this shape?
if you find me a regular, I'll it's the right angle.
Oh, wait. What's a right angle?
The,
Is it?
It's a linear pair.
It's only a parallelogram, right? Well, now we got around to something. These are linear pair.
So you just add it.
Or, yeah, do we remember something about exterior angle theorem? Is X an exterior angle to that triangle? Oh, yeah. You could do it that way. Do 180 minus that, get this angle, and then 180 minus it, right? But an exterior angle is equal to what?
65 plus 70.
So, yeah, exterior angle theorem, right? We could use that. So X equals 65 plus 70, right? Which gives us 135 degrees. You could have done it the other way, finish out the triangle angle, did a linear pair, but isn't that how we kind of proved the exterior angle theorem anyway? Right? Is it, wait, 7, 6, 30, yeah, 135. We good on that one?
Yeah, double.
So, okay, what's the measure of that angle then? 45. What is 180 minus 45? 135.
I mean, finding the measure of O and K.
Of angle O?
Yeah.
Oh, okay, so I see what you're doing. You're going to work within the quadrilateral, aren't you? All right, so you know what he did? This is not bad. So a little bit more work, but valid. These are consecutive angles, right? In a parallelogram, what's your properties tell you about that? Consecutive angles in a parallelogram are what? That means they add 2. So what's the measure of angle ROC? Is it? This and ROC add to 180. 110, right? And then opposite angles are congruent, so K is what? What is that? I don't know. This is 110, you told me. So K is what? 110. Now, the only thing we're missing, though, huh? Yeah, I mean, so that plus that plus that plus that add to 360. I don't know, can we get this angle? How? Like why? Oh, yeah, okay. Right? 110 minus 65, what is it? 55. 40. Yeah. Is it 45? 45. And then they all add up to 360. You could do it, so I'll bet you get the same answer doing it that way. There's more work, though. All right, sometimes there's more than one way to skin a badger, and there's a harder way to do it, and an easier way. Probably a harder way is when the badger's still alive. Imagine that would be dicey. Here we go.